Hello everyone and welcome back to the ccubed channel. This is a tier 1 video, meaning that this is aimed for foundation levels maths students taking GCSE maths and Excel exam board, and it is also for those people who want to start from the absolute basics. So today we're going to be taking a look a little bit into the function notation and substitution. So again, this is a bit of this isn't quite related to the last two videos, which is solving equations, rearranging subjects and such, but this is more of looking back at things like terms and even just well, yeah, I guess it's just mostly like terms really, but we'll see. So the idea with today's session is this notation right here, f of x, and we're going to be taking a look a little into what that is. This is also kind of a precursor to graphs, graphing, which will be a separate set of stuff that I'll be covering, in another time. For now, this is mostly focusing on pure algebra, no graph stuff yet. But when we get to that, I'll be looking back into graphs and we'll be talking about the function notation again. But functions do appear a lot in algebra, so that's why I put it here. So, to quickly start off with functions. So, a function is basically an expression, or essentially it's just an expression that takes input values, pass it through the whole, they pass it through an entire expression, and then you get an output value at the end. And these are typically done with something called function machines. There's kind of an elementary level there, but we have something. So this example here, this is a function machine. We have an input, and then we have an output, and then we have some we have some instructions in the middle. So let's quickly go over this kind of function machine. So we take an input, so it's any number. Basically we take a number in. So let's say, I don't know, let's say 3, for example, 3, yeah? So, and now we have to add 3 to it, so it's going to be 6. And then we multiply it by 2. So 6 times 2 is 12. And then the output is quite literally given as 12. So we get an input of 3, and we get an output of 12. And this is kind of a foundation for graphs as well, and that's basically how most graphs are plotted out. Actually, you take the input, and then you get the output. So the input would be, say, on the x-axis, and then the output would be on the y-axis. But we'll be taking a look further into that at a later point, when we do geometry measures and all that kind of thing. But for now, we're going to do kind of like an algebraic approach. So this can be represented in an equation form, which is down here. Y equals 2 times x plus 3. Okay, so it's not exactly too clear as to how this, how these two link up, but so we're going to kind of break it down a bit. So the input is the x right here. So this is the input right here. So x is the input. These are the numbers that you put in, right? And then the first instruction, add 3, is here. So it's x plus 3. That's the first things you do, is in the brackets. And then you multiply by 2, which is this right here. So whatever value you get in here, you multiply it by 2, which is what we've done. So if x is equal to 3, then 3 plus 3 is equal to 6, and then 6 times 2 is equal to 12. And then you might probably guess now the output is y, which is right there. So that is kind of the breakdown of an equation like this. So this here is an example. This is an equation of a straight line, a type of straight line. We'll be looking into that when we look into y equals mx plus c as such. But for now, we're just going to take it as this right now, and that's it. So we have that. That's all we have for that. That's good. And this kind of feeds on into looking at something called the function notation. So there is another way that you can write y, as we see here. So graphs typically use y for output values, as we have seen there, like output there. But you can also write those as f of x. So that literally means function of x. So this could be just simply f of x. So so the function of x could be 2 times x plus 3. So, whatever thing you do in the middle, whatever values you put in would affect the value, for example. So basically, these two, so you can actually just equate those two together because y and f of x are exactly the same thing. They mean the same thing. You can actually just write y for any other value. You can even make f another kind of value for a different function, but at the kind of standard at maths level, early maths levels, this kind of form. And as I've written here, any expression can go in f of x, as example we've seen right here. So y is equal to f of x, but you can make y equal to 2 times x plus 3, so that's the example. And we can see it again right here. So f of x is equal to 3x plus 1. So the function of x is equal to 3x plus 1. So basically, in this case, x is the input, and then f of x is the output, right? And this is acting on the input, which is x. So that's a way to think about it. The function of x is kind of like acting on the input, which in this case is just x. That sounds kind of like a mess in my head, but it basically works out like that. So anything you have in the brackets is basically what you would is basically what you would be looking at in the actual expression. That's a simpler way to put it. Now, let's go and take a step back from graphing stuff now, and let's go take a look at substitution. So we have actually done substitution quite a lot in these videos without really acknowledging it. I've talked about, when solving equations, sometimes you can put the numbers back in to check if they work. That was an example of substitution that I just never mentioned. So now we're going to quickly look into it a bit more. So substitution is essentially a process where you replace variables with known numbers, or you can have other expressions or other variables. So a quick example here is y equals 5x, where x is equal to 1. So in this situation, you quite literally put 1 into x, because you're told what x is, so you just plug it in. So this is equal to 5 times 1, and 5 times 1 is just simply 5. And that's it. Done. So that's not too bad, that's not too crazy. So there's another example now using the function notation. So f of x is equal to x squared. Now we have this interesting situation here where we kind of implied that x is equal to a number. So we said f of 2 now. So it's a function of 2. And what that means is we are quite literally saying that x is equal to 2. Because you see x appears here and 2 appears here. So this is kind of like an equality right here. And we are using the same function because of the f in front. If this was, say, g or h, then we would not be talking about this function up here. We'll be talking about something else. So the distinction to make, well, the kind of thing you have to realize is the f stays the same, so we are talking about x squared, and x is now a 2, so we're saying that x is equal to 2. So quite literally, this means 2 squared. And that is equal to 4. Now this is important. This is an important thing to do. This will help a lot when it comes to things like graphical transformations, and looking into trigonometry stuff. It will even help with physics as well when we do the physics stuff. That kind of thing. But we are going to see this a lot. Fairly soon actually. This is going to appear quite a lot. So this is something you should kind of get familiar with, this kind of notation. So let's do 2 more examples now where we're using expressions and variables now. So let us say in this situation we have the equation here, xy equals 2, okay? But we've said that x is equal to u plus v and y is just equal to u. So we're substituting 2 different things here. So let us go ahead and substitute them individually. Oh god. So x is equal to u plus v. So we're going to do u plus v. Alright, and now we're going to substitute y in, which is just u, and that is equal to 2. Ooh, that's about 2, but yeah. Now, you could just, you could, expand that out or leave it be, so let's just quickly expand it out. It's good to have the practice for this anyway. So remember u times u, and then plus u times v. So, plus uv is equal to 2. And that is all we get for that. Quite interestingly, we've kind of actually created something called a quadratic equation, but we will be looking into that in a future video, and not now. So don't worry about this right now. We're just gonna leave it be as hey, u squared plus uv equals 2. That's the thing. We'll just substitute it. So yeah, using these, we pretty much having this new thing now. Okay. So that's kind of the example of using expressions and variables for substitution by just saying that x is equal to u plus 3, which goes in the left one, and then y is equal to u, which goes on the right one, which is u, and then So again, this is extremely useful. When we do calculus stuff, we're going to see how this is especially very useful for things like integration by substitution, which is a second year A-level maths, technique. So yeah, integration by substitution is incredibly annoying from my own experience, but this method is essential. You have to know how to do this kind of thing to be able to do it. But again, that's too far in the future. We're not talking about that. We're talking about basic algebra, so don't worry about that much. And if you're not even going to go into A-level maths, then just don't listen to that anyway. Alright, final example. So we now have f of x is equal to 2x minus 3. And we have been told we have f of x plus 1. So this is a new kind of, expression here, I should add. So we are substituting the expression here. Similar thing to what we said here. We said that, the f's functions are the same. So we are talking about this function here. But the variable in the middle is different in the brackets. So instead of it being x, we now have x plus 1. So every time we see x, you just replace it with x plus 1. That's the substitution. So let's do that real quick. So we can now have 2x plus 1 minus 3. And that is what we get now. So we could go ahead and quickly just, expand that out. Let's do 2x plus 2 minus 3. And 2 minus 3 is equal to minus 1. So in the end we just get 2x minus 1. And that has changed the, the final value. So f of x plus 1 is equal to 2x minus 1. That is essentially what we've kind of got here. And that is pretty much all I have to really say on substitution. That's kind of the standard, is just, you take values, you replace the numbers with different things, you replace the values with other stuff, and yeah, that's all there really is to it. There's nothing really major about it. This is extremely a useful technique, as we'll see. We'll be using this a lot in future videos, and obviously when we go further on, we're going to be looking more into that kind of thing. So thank you guys so much for watching, and I'll see you all in the next video.